To initiate a pre-programmed automatic thin film sputtering process recipe, the operator loads a substrate pallet onto the upper level of the 2-level load lock elevator. The operator then closes the load lock access door and depresses the Good to Go button located on the diagnostic maintenance panel. The load lock chamber roughing valve will open and the 27 CFM direct drive mechanical pump will start to rough vac pump the load lock chamber until a pre-programmed set point is met on the Granville Phillips 307 ionization gauge controller. After the initial roughing set point is met, the high vac pneumatic gate valve will open and begin the high vac pumping sequence of the load lock chamber. High vac pumping is accomplished by a dedicated CTI-8 cryo pump to a second pre-programmed high vacuum level set point. Once the load lock chamber high vac set point has been achieved, the load lock chamber is ready to initiate a pallet exchange between the load lock and main process chambers. The pallet exchange sequence can now begin. The pallet exchange sequence is accomplished by a series of vertical up and down positioning steps by the 5-level load lock seal plate. Upon completion of the exchange process, the pallet will be loaded into the main process chamber onto the pallet carrier. A finished process substrate pallet will be placed on the lower level of the load lock elevator. At this time, the load lock elevator will be raised to its highest position level and its seal plate will isolate the two chambers. The next step involves re-establishing a suitable high vacuum level in the main process chamber. At this time, the GP307 gauge controller will be automatically switched to monitor and control the main process chamber's high vacuum level, as it is being high vac pumped by the main chamber's CTI-8 cryo pump. Once the main chamber's high vacuum set point is met, the system is ready to start an automatic pre-programmed process recipe. Typically, an initial substrate pre-cleaning step is performed by a RF sputter etch process on the RF etch platform. The 2-position RF etch platform will rise to the upper position, process gas will turn on, and RF power will be supplied to the etch platform and the substrate pallet. Plasma ignition is accomplished automatically by MAT-VAC technology special software without the need of a glow start plasma igniter. Once the RF plasma ignites, the automatic tuning network will tune the plasma. The gas pressure will stabilize and etch the surface of the substrates for a pre-programmed amount of time. Once the RF sputter etch process is completed, the substrate pallet will be realigned under target position 2 and sputtered with RF power. The RF power level is now ramping up. Once the RF power reaches a pre-programmed level, the pallet scan will be initiated and the pallet will pass under target position 2. After a pre-programmed number of scans, if a substrate cooling step has been pre-programmed, as it has in this demonstration, the pallet will be repositioned onto the water-cooled RF etch platform. The platform will be raised and the pallet will be cooled for a pre-programmed amount of time. This substrate cooling step is unique to the MAT-VAC system and can be pre-programmed at any stage of a process recipe. Now that substrate cooling is completed, the pallet will be placed back onto the pallet carrier and relocated to the left side of the main process chamber in preparation to be exchanged out. Once the exchange process has been completed, the load lock chamber will be vented to atmosphere and the load lock access door will open automatically. The process substrate pallet is on the bottom level of the 2-level load lock elevator. The processed pallet with the completed parts can now be removed and a new pallet to be processed can be positioned on the top level. The sequence cannot be repeated with the same pre-programmed process recipe or a completely different process recipe. We hope you've enjoyed this video and thank you for watching this presentation.